the data center power challenges basically from a practitioner side. Okay, hopefully give you some new perspective. But before I do that, you guys can hear me?
Yes. Yeah.
Before I do that, 2024 is the year of dragon. A very special year for Chinese culture. So I wish everybody a fantastic 2024. May all your beautiful dreams come true. So let's talk about what happened in the data center. And we talk about a little bit about AI, talk about data center power and cooling challenges because of the AI. And also talk about Supermicro, green computing, why it's a perfect solution for the AI era. That will end with 2024, AI trend and data center prediction. Okay. So last year is the year of AI. But at the beginning of last year, at this time, people talk about our world, right? What is our world? It's the recession. Because at this time of last year, we have high inflation. The economic future is very uncertain, right? So people have lots of concerns about the economy, the overall IT industry. But what ChatGPT or OpenAI did is it proved for the first time that when you use the transformer-based large language models, when you feed those models with very large data set, I'm talking about all the data available on the internet, and you couple them with enough GPU compute, magic just comes out, profit comes out, money comes out. So when people realize the power of this formula, what happened? This AI infrastructure arms race literally just happened in February, March timeframe. Everybody wants to get their hands on the NVIDIA GPU. Right? Any NVIDIA people here? No? Okay. So everybody wants to get their hands on GPU. They give literally PO just waiting for allocation. Right? But when people buy AI infrastructure, they don't consume GPUs. They consume the AI servers. They consume the total AI solutions, packaged and validated, delivered in a whole rack. Okay? So there are a few dozen OEM vendors in the world, right? So the billion-dollar question is why Supermicro? Okay? So I have some quote from CNBC, from Digital Times, and also from the next platform, last couple of quarters. Right? So Supermicro is a major AI infrastructure provider for the industry. So the billion-dollar question is why, right? So I'm going to peel the onion one layer at a time. Then I'm going to come back, revisit the billion-dollar question, and hopefully give you more insight. But most importantly, I'm not here to give storage tips. Don't buy, sell stock based on my talk. Okay? So the data center challenges in the AI era. So in order to understand this challenge, we have to understand the difference between an AI server and a regular cloud server. Okay? So the AI server, especially for the high-end training servers, it has 8 high-powered GPU, plus 2 high-powered CPU, plus lots of memories, plus lots of other stuff. It consumes up to 10 kilowatts today, a single server. If you look at the hyperscale cloud server, when Google started building their cloud, they pioneered this pizza box, right? Literally just like pizza-sized box with 2 CPUs, consumes only a few hundred watts. Okay, so that's why I think Rob also talked about this. You can build a high-density data center using pizza box. Only consumes about 10 kilowatts, the whole rack, okay? But in the era of AI, one server consumes 10 kilowatts. But what does that mean to the data center? What are the challenges? Well, challenge number one is there's not enough power being fed per rack. Because all the data center built today, I would say most of the data center built today, especially the hyperscale data centers, they are built at 15 kilowatts per rack. So you guys can do the math. How many AI servers can you pack into a 15 kilowatt rack? One, right? That's a huge problem. The problem number one, if you want to build AI data center using the traditional traditional colos of data centers, your TCO is going to be very high because you are not using all the data center space. You actually use lots of data center space in order to run AI servers. The second challenge is you have a huge hotspot in a data center. What I mean by the hotspot, when you have an evenly distributed rack with lots of dense servers, your cooling, your thermal is evenly distributed, right, throughout the rack. It's an easy problem to solve. But when you have a hotspot, basically one or two really, really hot servers, when you're trying to cool them with air, it's a huge challenge. Okay, so that's one of the big differences between cloud data center and AI data center. So the other challenge is, as I alluded before, the AI infrastructure also needs density. That's how you bring down the TCO. Okay, so people are scrambling to build new data center that can accommodate these new AI servers. But you might ask, what is the problem? Just build more data centers. Well, if you try to build a new data center, it takes a long time. Okay, you need government regulations, you need power, you need lots of stuff. It could take several years. Okay, so it's a huge problem for the industry. So I want to look at this from a macro environment perspective. Basically, data center operates in our environment, right? The only planet we have. But the surface temperature on Earth has been rising over the past 100 years. Okay, so what the data says here is the surface temperature on Earth, where the data center operates, has increased roughly about 1.5 degrees Celsius since the first industrial revolution. Okay, so right now we are at the fourth industrial revolution. So why this is a problem? Because data center need to operate at a higher temperature. They call it ambient temperature. That's your starting point. And you need to bring down the ambient temperature to lower degrees because most of the IT equipment has a lower temperature, operating temperature requirement. Some require 25 C, some require even lower. So if you go to a data center, you will notice it's very cold. It's cold for a reason, right? So you have a rising temperature, but how about cost? Data center needs lots of power, lots of energy to run, lots of power, but the power cost is rising, right? It's much faster than inflation. I know there's pretty benign inflation reading, I think from yesterday, but the power cost is rising at a much higher level, order of magnitude. So, at my dinner table yesterday when I was talking to my wife, we have two topics. The first one is both of us are watching this new TV show from China called Blossoms on Shanghai, or Fanhua, right? She's watching Shanghai dialect, but I'm watching Mandarin. So we are sharing insights, takeaways, and different interpretations. And the second topic was, we just received the PG&E bill for this month. We were shocked. There's a huge spike, right? Huge spike. So this is really a huge problem. So if you, again, looking at both factors from a data center perspective, it's a double whammy. Because the temperature the data center need to operate in is rising. That's number one. Number two, the power cost is also increasing. So in order to power more GPUs, CPUs, we need more power, we need to create more energy, and that's more impact to the environment. And the cost is going up. It's also TCO and also, again, huge implications for every sector of the industry. So what is the solution? So at Supermicro, we are working hard to try to solve this problem by introducing more energy efficient servers. Okay, this is something we call green computing. I will touch upon this a little bit more as we move forward. So now let me give you a quick overview of what Supermicro does, and hopefully you have a better understanding why the green computing we are doing is really critical. So Supermicro was founded 30 years ago in Silicon Valley. If you guys recall, if you guys old enough to recall, at that time, what is going on in the world? Globalization. People are trying to outsource to Asia for lower cost, especially for hardware. Because people are talking about software is going to eat the world. Hardware needs to go somewhere else, right? So under this type of environment, so when our CEO Charles was trying to found Supermicro, he's looking for funding. And basically people were telling him, hey Charles, if you want to start a hardware company, you should not do it in here, in Silicon Valley, the most expensive place in the world. You should go to Asia. If you try to do it here, you are not wise. So when people say you are not wise, what they are really saying is you're stupid. Right? So it's not surprising that Charles could not get any funding. I mean, zero. Okay? But he started Supermicro with family, with friends, no outside funding. So fast forward 30 years later, Supermicro has a huge presence in Silicon Valley, not only research, development, engineering, but also manufacturing. The benefits of having local manufacturing here is our engineer can go to the production line and fix the problem right there when the problem arises. Okay? It's reduced the time to market, improves quality, it's just so many benefits. So our presence is also in Taiwan. We have a huge presence in Taiwan. We have worldwide sales offices. We also in the process of adding a dozen more sales offices throughout the world, in Asia, Europe, and the Middle East, and another growth engine for many companies. So I'm going to show you some pictures here. So the picture on your top left is the Bada campus, just outside of Taoyuan Airport in Taiwan. Okay, it's huge manufacturing and research development campus. If I go counterclockwise, it's the second building I'm showing here is right here, just off Brookhart Road, near the 880. That's our, we have a huge campus here, just there, right? And also, if you drive through 880 on Saturday, every Saturday morning, around 11 a.m., you will see a white Mercedes-Benz SUV parked in the same spot every Saturday. Okay, every Saturday, until very late in the Saturday. That's our CEO Charles. He goes to work every Saturday. Okay, he's multi-billionaire, but he's still work as hard as if he just started the company, because he has a huge passion for green computing. Huge passion. The other picture, just again counterclockwise, those are the campus that we are building in Johor, Malaysia, just across the bridge from Singapore. It's going to double, triple our manufacturing capacity. when it become operational in the first half this year. So another metric I want to share with you guys is we are capable of producing 4,000 racks per month globally, okay? And we are expanding. We actually expanding our manufacturing here in San Jose as we speak. We are building a huge facility, 10 megawatts, just dedicated to do rack level burn-in and validation. So we can do hundreds of racks of burn-in simultaneously at the same time. So let me talk a little bit about Supermicro's product offering, which is already very different from other vendors in the industry. Supermicro is very well known in the industry to offer the broadest product portfolio. Okay, from edge to cloud, all different form factors. So on the top we have blade servers, we have rack mount servers, we have storage servers, we have multi-node servers, we have GPU servers, which is very, very popular. Even in the GPU server space, you have different form factors because there are many different use cases, many different applications. And also for the edge computing, smaller form factor, different power, cooling requirements, we have lots of product offering in this space. So this is critical to our success because we don't believe one size fits all. Okay? Many of the other vendors, they have a Swiss Army knife approach when they develop server products. What that means is they're trying to develop very few products used, then they're trying to retrofit to every use case, every application. We don't believe in that. We believe in application optimized server. How many people here buy the same size shoes for every family member? I saw it's an alien. It's not from the Earth. Anyway, yeah. So, but there's a way we are doing this. Anyway, I'll talk a little bit more about how we do this without increasing the cost. Right? It's not only at the server level. More and more AI customers, they're consuming this solution at the rack level. Because if you think about the AI arms race, what the customer is looking for is time to market. It's the availability of the GPU computing, so that they can develop their large language models. Okay? So they can go ahead of the computation. So they want everything delivered, ready to go at the rack level, including AI servers, compute servers, management servers, storage servers, switches, cables, power supplies, everything fully integrated, fully validated. All the software. Think about how many software involved in a rack level solution. How many components? How many devices? There's lots of technical know-how and value add that Supermicro provide to our customers to shorten the time to value for our customers. So another huge differentiation from Supermicro is we are really fast. We do things really, really fast. Okay. So the time to market is a huge advantage of Supermicro. I will talk about why we're doing that and why we are able to achieve that. So some of our partners and customers, when they describe Supermicro, they always say Supermicro is the first rabbit out of the rabbit hole every single time. Okay, so that's one of the huge differentiation aspects. So I'm talking a little bit more about how we do the broad product portfolio without duplicating the engineering resources. Right? We call it building block design approach. So when Charles first designed founded the company, this building block design approach is the main design philosophy he has instilled in every design engineer. So what that means is we develop, let's say, a motherboard. The motherboard can be used in many different systems. okay? So we don't need to develop a single motherboard for every system. We use the same motherboard for a few different servers with different type of chassis and different type of power supply, right? We also develop power supplies. We develop the basically all the key components used in the server. Okay, so we have total control of our testing. So Silicon Valley advantage. Silicon Valley is such a magical place. You can, no matter how you think about it, this place cannot be replicated. Okay, I moved to Silicon Valley about 12 years ago from Boston. Okay, Boston used to have a 128 high-tech center, right? Boston has lots of good schools, lots of technical resources. They have money, but what they don't have is the weather. Okay? They don't have the weather. I can tell you how hard the winter was. Every winter, I stay in my basement and become depressed. I'm not kidding. I'm not kidding. Every day, during the winter, what everybody's trying to do is go home. If they don't go home early enough, they get stuck when it starts snowing. Okay? So, talking about another place, I know I'm from Texas. I love Texas. I love barbecues. But it can be too hot in the summer. Okay? I have a few friends living there. You can go up to 120 degrees. Yeah. It's hot. When it's too hot, what do? You chill at home and barbecue, right? Drink beer. You don't want to go out to work. Right? Anyway, so Silicon Valley is such a magical place. And also all the great partners are here. When the great partners are here, all the innovation just moves faster. Moves so fast. Okay, we have NVIDIA, literally our great partner NVIDIA, 2 minutes away, 5 minutes away. We have Intel, we have AMD, we have Broadcom. Broadcom, by the way, they are on the same campus as Supermicro. We literally just walk to their building when we have a problem with their products, right? The PCI switches, the RAID, literally just walk across the street, okay? So another huge advantage Supermicro has is on the same roof. So what do I mean by under the same roof? Supermicro has all the design capabilities for the server, for the rack, for the liquid cooling. We don't outsource. We don't go to other people. We do everything in-house. We have vertically integrated capability. This again shortens product development, improves quality. Okay, huge advantage. Another advantage, we spend lots of time trying to optimize the rack level solution for our customers. Right, L11, L12, everything. Server, storage, networking, compute, cables. If you guys ever visited a data center, just go to the back of the racks and look at the cable. Lots of cables. When it's lots of cables, lots of things can go wrong. Okay, lots of things can go wrong. It's lots of expertise required. So, another thing, green computing. Our founder, Charles, green computing is his passion, is his love. So he worked Monday to Saturday every week. You know what he does during the Christmas break? When everybody here is having vacation, he goes to Taiwan and work there because nobody in Taiwan is taking time off. The only time he takes off is Sunday morning. He has a Green Earth Foundation right here in the Fremont, Milpitas area. So he's trying to grow the most drought-tolerant trees species, and he's trying to replicate that in Sahara Desert. Okay, his Green Earth Foundation has a stated goal. He wants to plant 100 million trees, drought-tolerant trees in Sahara Desert in the next couple of years. Okay, he has a huge passion for green computing. So, how do you measure the data center power efficiency? I think Bob touched upon this This is basically what the industry is trying to do is to bring the PUE as close to 1 as possible. That means every watt goes into the data center is used to feed the IT equipment instead of the overhead, right? The overhead meaning the HVAC system, the power cooling systems, the lighting, right? All the other stuff. And conversion, right? When you convert the power from the power line outside to the IT equipment, there's lots of energy loss during the conversion. So the industry has been seeing the PUE fluctuates around 1.6 over the past 10 years. Not much progress has been made. But Supermicro is doing lots of things. We're trying to improve the PUE towards 1.05 or 1.06. Okay. I think Rob also touched upon this. The CPU, GPU is getting hot. Because I think as an industry, right, the semiconductor industry is trying to just pack more and more transistors, right, into the die and trying to put more dies on the same package and also trying to put the memories on the package. This is going to be slow. Right? So the second half this year, the CPU is going to be 500 watts at least. And the GPUs, the super chips, is going to be 1,000 watts. That's coming, literally in June, July timeframe. And the only way out from a data center perspective is that we have to look at liquid cooling. Because liquid cooling is order of magnitude more efficient to remove the heat than air. And this power envelope, air cooling is running out of steam. I think Rob also talked about the fans. Okay, there's lots of huge fans. I think I showed you and George. There's a brand of fan in the data center called Big Ass Fan. Big Ass Fan. It's big because you need to blow really hard and try to get rid of it. But that's not sustainable. So our CEO Charles has envisioned that in the next 7 years, liquid cooling is going to pick up. Liquid cooling is going to be being adopted by the data center worldwide. Because it is simply no other way around. Okay. So let me talk a little bit about the green computing from Supermicro. As I mentioned, we are targeting industry's best 1.05, 1.06 PUE. And how we do that? At the air cooling level, we have something called free air cooling. What does that mean? Free air cooling means we design our servers with energy efficient technology. So the server can operate at higher ambient temperature. Our servers, some of our servers, of course, it depends on the configuration, type of servers. Some of our servers are designed to operate at 35 C or even higher. So we have a great partner, Intel, that use our resource savings server in their data center. And they achieve PUE of 1.06 using free air cooling. Because all our servers operate at pretty much the Bay Area temperature, ambient temperature. And they have that number actually this year is 400,000 servers in the data center to support all the EDA designs that they have. So if you adopt this green computing technology throughout the industry will be able to save $10 billion in terms of the TCO, in terms of energy reduction, energy consumption reduction. And this also will translate into 8 billion trees saved worldwide. Okay. We don't need to cut those trees. All we need to plant 8 billion mature trees equivalent to get rid of the carbons, the emissions, and all the side benefits of increasing the power supply to the world. It's also equivalent to reducing the fossil fuel power plant, 30 of them every year. So this is why I think the green computing is a huge goal. It's a huge mission should be a huge goal for the whole industry. It's not just about profit, right? It's also about how do we save the environment and have less impact. So I promise you guys, I'm going to come back, revisit this building of questions after we review some comments. So why Supermicro? So I would say we did lots of things that's unconventional. We don't listen to Wall Street, okay? We don't do business, run our business based on some analyst advices, based on quarterly results. We don't, okay? So Silicon Valley, huge, magical place. We love here, we work very closely with all our partners. NVIDIA, Intel, AMD. By the way, NVIDIA also founded in 1993, the same year as Supermicro. Same year. Charles and Jensen has been great friends, pretty much at the very beginning. Two young persons trying to make it out in Silicon Valley. Okay? And Lisa, of course, is a wonderful CEO. Really did great things. Right? And you know, as Chinese, I think we should be all very proud of this. I think the semiconductor industries, we should be very proud. So the second thing we did, which is unconventional, is insourcing versus outsourcing. So again, as I mentioned, when everybody is outsourcing, trying to reduce the cost, bring the cost down, okay? Outsource all their engineering to Asia. We did. Well, we grow in Asia, but we did not reduce our engineering in Silicon Valley. We actually increased, okay, year after year. This is huge, okay? So I also talk about building block design methodology. This is very unique. I think the industry actually is starting to adopt some of the methodologies. I think Rob talked about a lot about this. OCP now have a new standard called DCMHS, which stands for Data Center Modular Hardware Systems. Very similar idea. Just build common motherboard, build common components, used for multiple generations, used for across multiple platforms. Same idea. Lego, right? Same approach. So another key, I think, things happen that is when this AI boom happened. The data centers got caught, really not prepared. Nobody anticipated the huge demand for AI server. At this time last year, nobody. Okay. But when that happened, the data center operators, they are not prepared. So who's having lots of GPUs at that time, this year? The crypto mining people, right? Well, what happened to the crypto last year, this time? It crashed, right? They crashed. So all those people, they're trying to pivot to something else. So they started building this GPU optimized cloud for AI training. There were a few companies, nobody heard. This time last year, they are multi-billion dollar company. Multi-billion dollar company in a span of 12 months. But why Supermicro got connected with this GPU cloud providers? So remember the rabbit hole analogy I was using? Because we're the first one that has product ready. In that time frame, nobody else has it. Because they all source their design engineering to Asia. Nobody's developing the GPU servers. What else happened in that time frame? PCIe is transitioning from PCI Gen 4 to PCI Gen 5. And PCI Gen 5, high speed, right? More bandwidth, lots of signal challenges. People are not ready. But Supermicro was ready. That's why. Okay? Not because they love Supermicro. I would love to think that's the reason. Another reason which is very critical, Supermicro will keep investing. We are keep investing to scale our capacity, scale our engineering design capabilities, put us in a better position to compete or whatever comes next. So I'm going to wrap it up with some AI crystal balls. Okay, what's going to happen in the data center this year? I think this year, last year, by the way, was the large language models, right? We need to train with all the data on the internet. But this year, people is going to go to the verticals, right? The different industries, the biotech, the drug discovery, manufacturing, financial fraud detection, healthcare. You need to go vertical. You need to train the smaller language models, but with domain-specific data. Okay, this would be huge. So this will drive the AI growth, not only on the training side, but also on the inference side. So another trend we see is people is going to build country-specific language models. So when ChatGPT was built with English language, right? Many countries in the world, they want to train the language model with their own language. Because the culture is always local. You have to understand the context, right? So lots of countries try to build their own sovereign AI cloud. The data cannot go out of the country. So lots of countries try to build their own country-specific LLMs, train them with data in their own language. This will be a huge trend. So another trend we see is multimodality. What do I mean by multimodality? So when ChatGPT first came out, it's text prompt to text. So now what are people doing? It's from text to image, text to 3D image, text to video, text to executable code, and make it bi-directional. This so much work needs to be done, but it's also very exciting. Right? So the second trend that I think may happen this year is AI inference is going to be everywhere. Right? So if I use a simple analogy, so AI training is like when people study in school, they spend days and days trying to master a subject. But AI inference is when it's trying to take the exam, trying to take the test. Okay. But the AI inference this year is going to be slow. It will be on your phone, on your laptop, on the AI servers in the cloud, running on the CPUs, not only on the GPUs. There are so much advancement in the CPU side. Some of the AI inference workload can be run on a CPU. You don't need the GPU anymore, especially at the edge. So another thing we see in the data center, again, from architecture standpoint, is architecture divergence. What do I mean by that? If you look at some of the new architectures that's being driven by some of the leading vendors in the industry, they try to pack the CPU, GPU, and the HBM memory on the same package. There's no more DIMMs. You don't need DIMMs, right? Everything on the same package. There's no more. It's just much simplified compute architecture, right? It has lots of benefits, but the scale out is still unproven, right? We see how that play out. On the other hand, some of the CPU-centric vendors, they are pushing a different technology called CXL, which is based on the PCIe Gen 5, and in future, PCIe Gen 6. So what they're trying to do is, they're trying to put the GPUs, the memories, the storage into a storage pool, GPU pool, memory pool. So when you scale your data center, you can just scale the independent pool, right? This is why it's called disaggregated. So these two technologies could not be further away from each other. So how this is going to play out, whether they solve a different problem, different use case, remains to be seen, but it's very exciting. So we talk about liquid cooling, it's going to gain momentum this year. And last but not least, how far away are we from AGI? artificial general intelligence, right? When we build emotions, consciousness into AI. So I talk to lots of smart people in the industry. I got very different answers, right? Some people say that AGI is not in my lifetime, which is very depressing. Okay. Some people say, oh, I'm doing AGI this year. It's coming, right? So when I think about it, I think both make sense. It's really depending on the definition of AGI, right? It's depending on the definition. So when Zuckerberg was talking about, building the GPU cluster this year, by the way, he's trying to build 350,000 H100 GPUs from NVIDIA, but his total GPU from other vendors, equivalent H100 is going to be 600,000 this year. 600,000, right? He's trying to build AGI right now. So I think on the AI front, I can honestly tell you this thing just gets started. I think the AI industry, which has a huge implication on the power industry, is going to grow rapidly over the next 5-10 years, 50% plus every year at least. So it's a very exciting time for us in this industry. That's all. Again, thank you for the opportunity.